let's do our practice exercises for the hole inspection gauges that we've just covered. Go ahead and visit the Pragmatic Metrology website, and you can find this practice exercise worksheet as well as print for the PM02 angle block. You can find CAD model for this if you want to 3D print it. If you want to make it yourself, you can use the print to do that. Or you can substitute your own part if you have one. Maybe you want to find some similar feature parts, or maybe you have a collection of parts with a variety of holes. But I'll be demonstrating how to use all of these holes to inspect this print. And while you're at it, why don't you go ahead and download the worksheet to fill out your measurements as you're working. This worksheet resembles what you'll do, what type of worksheets you're going to fill out in industry when you're filling out inspections for first articles or in processes or even final acceptance. So grab one of these, you can check your work later. So let's get started on understanding the exercise. So go ahead and download the PDF that I have up on the website and follow along, or read up on the screen. I'm going to read off of my copy here. So we're going to need our gauge pins, our hole mic, setting ring, telescope gauges, the OD mic, small hole gauges, an OD mic, tubular inside micrometer and OD mic, and dial bore gauge and dial hole gauge. So if you don't have all those tools, that's fine. I'm still going to demonstrate all of those. We'll also need our caliper because we're going to be giving ourselves a little sanity check for a lot of these measurements that we're doing. So get your digital caliper, keep it nearby. So the goal of the exercise is to practice using the specialized mics and compare to the standard OD mics and calipers that you probably have done already. Go through the calibration checks for each gauge, study the prints for opportunities to use new styles. So this is another opportunity where we've got a bunch of other gauges. You know, if you've watched the surface plate videos, if you've watched the specialized micrometer videos, angle videos, you'll know that sometimes you have a lot of options of what you can do, and the hole inspection is that similar case. So we'll look for new opportunities, try to figure out which gauge is best for which situation. So for each gauge, we want to go through these steps. First, identify its size range so you know the limits of the gauge. Sometimes it'll just be engraved on the gauge itself, so it should be fairly easy to spot. We're going to check the calibration of each gauge before we use it, which you should always do before you're using a new gauge. For the parts selected, which is this one, we're going to measure each hole with all the gauges that will fit and compare. So for step 3, if you're going to use the angle block, I have a grid of the gauges that will work for each size of hole, assuming that you have a gauge in that range. But for the most part, these gauges are commonly available in these sizes. So you may have them in your shop or in wherever you're working. Then last one, practice getting a feel for the gauge with a calibration standard. So for each one, calibrating each one's a little different. Some of them won't have, telescope gauges won't have a calibration because they're a transfer gauge. So but just make sure you're developing that feel for 0, because every time you use the gauge, you need to make sure you're comfortable setting it. So I'm going to bring up the grid, and once you follow along with your own copy, if you print one out. And let's get started. We will start off with the gauge pins. We'll go in the order, and we'll inspect a few of these holes. We won't necessarily inspect everything for the sake of time. Let's flip over to the other camera. Remember, you can always watch the camera feed directly off of this camera here, and it looks a lot better than it shows up on the TV. So we will get started with our gauge pins. I have my gauge pins here, and we're going to look at our print, and we're going to figure out our tolerance so that we can select the right pins. So for pin gauges, it makes sense to do go, no-go gauges. So I'm going to select the go pin and a no-go pin. The go pin is going to be the smallest size that's acceptable. The no-go pin is going to be the largest size that's acceptable. So for this 397 hole here on the bottom, the go, no-go sizes are going to be 392 and 402. And we're going to verify those on a micrometer. Make sure they're the right size. Make sure they haven't been worn away too much. That's just a hair under 392. And these are minus pins. As I talked about in the video, minus pins are going to be smaller, up to 2/10,000ths. So both of those are in. Both of those are identified correctly. And we're going to run the 392. Very easily runs through. Run the 402 and doesn't go. I think we have another 397 hole on here, so let's take a look. We have a 397 through all in this counter bore hole. If you can see that, a little hard to see on the TV because of the shadows, but there's a 397 through hole. So here's the 402. This would be our no-go, and it won't start. Okay, so the no-go won't go. This is our 392. It also won't start. Isn't that interesting? So it starts from one side. I've got it to go in this side of the hole, but I can't get it to push through. So if you're a machinist out there, if you're an inspector who's inspected parts like this before, what do you think happened? I have a fairly good idea of what could have happened. I've seen it before. CNC machine drills the hole from this side, counterbores from this side, do all the machining, flip it over, deck it, and countersink. And when they countersink, it looks like they push a burr into the hole. So if I really try to force this pin through, I would probably loosen up a burr that has formed right around the ring, where instead of cutting that middle out for the countersink, just for facing purposes, they put a tiny little countersink, but they pushed it down. So I'm gonna go one size pin smaller. This is the 391, and it goes just fine. So there's a tiny little lip in this hole. And the 392 just doesn't want to go through. So it's right on the border of when, you might accept it anyway. It's just a tiny little lip, but you may want to ask somebody if you're not comfortable passing this part on your own. For me, I would probably just run a tiny bit of Scotch-Brite or sandpaper through there, knock that burr off, and it'll be good to go. But that's why sometimes you check with pins all the way through, and you'll find it stops because of burrs. And if this happens at assembly, yeah, a bolt is probably going to have clearance and fly through, but can't always assume a bolt is going to be going into that hole. So could be precision diameter that's going through and will stop, just like our pin gauge did. So there's a few other holes on here. The 375 plus 5/10 and minus 0. Well, in this set, I have a set here from, what do I have, 251 to 500. So I definitely have a 375 in here, but I don't have a 375 and a half. They do sell sets that are at the half increment, but I don't have that. So we're gonna at least grab the 375 and the 376, even though the 376 is out of tolerance. It will be a good sanity check. All right. So I've got the 375 and the 376. Let's verify these with the micrometer right before we use them. And again, just a hair under. These are minus pins. And 376 is just a little bit under as well, but makes sense. So we're going to use them. So the 375 pin should go in, and it's much looser than I would like. I don't know if you can see that on the camera. It's wiggling a lot. Let's put the 376 in. Ooh, 376 flies through. And we already know this 376 pin is out of tolerance. So that hole is obviously manufactured a little too big. Let's find the upper bound of that while we're here. Here's the 380, and it wants to start. And it goes a little bit of the way in. I can kind of wiggle it down. So I'll try one fewer. I'll try the 379, and 379 goes. So looks like they ran this part, maybe a little too quickly. Maybe they grabbed the wrong size cutter. Either way, it's way out of tolerance for this spec. So we could reject the part based on this. Quick and easy way, find it with a pin. You probably could also see it with a caliper. So because it's so far out of tolerance, you should be able to obviously see it. No, there's the 378. Sorry about the shadows. There we go. 378. So that's pretty much it for what I can do with the pin gauges I have and this part. The next step is to use the hole mic on either the 625 or the 970. Here's the part. Lost track of it. So this is the 625 counterbore. This is the 970 through hole. And I don't have any 3-point hole micrometers to measure this one. They certainly are available, but we're going to measure the 970 with the one we have. So this is going to be a repeat of what I did in the training video. But first thing we're going to do is verify our calibration. So I've got a 1-inch ring gauge, and I'm going to verify that the micrometer reads 1 inch. Now, if you look at the sleeve, it's it looks like it's reading 1 inch. By my eyes, it looks like it's reading about 25 thousandths too big because I can just see that line, and I shouldn't be able to see it at 0. So if you watch the calibration video, or sorry, if you watch the training video where I calibrated this and I warned you, you might be able to see that line. If you calibrate this wrong, that's exactly what I did. So I feel a little embarrassed to realize this on camera, but I'm gonna fix it now. So we're gonna loosen the screw again. And if you just wanna skip ahead a minute or so, should be quick. All right, so I'm gonna push, all I'm doing is pushing the sleeve higher up so that I can't see that second, so I can't see the first line, the 25 thousandths line, and I'm locking it down. I'm gonna recheck my seating. Let's see, I'm about 2/10 off. I'm gonna try to fix that, but I'm not gonna spend all day if I can't get any better than that. So I'm gonna loosen it. I'm gonna use the wrench to kind of twist it. All right, let's try that. Ooh. Careful not to strip that screw. Sooner or later, it always seems to happen, but be gentle with it. All right, now, from my point of view, it's just maybe 1/10 under 1 inch, and I'm gonna live with that. I don't want to chase this around all day, so I might be 1/10,000th off on my measurements, but for the tolerance of this hole, I have plus or minus 10 thousandths, so I can afford that little bit of error. So when you are checking a ring gauge, just like checking a part, slide it in, engage it, and click 3 times. Should hear that on the video. Oops, I had it at a bad angle. It's still wiggling. So I'm going to extend it some more. Do it again. And then twist. When I can't twist them apart very easily, it means they're engaged, and you can check your reading. So I am just a hair under, but we're going to keep going. So now we're gonna measure our hole. It's pretty easy. First thing I'll do is measure the top side, and I get right about 970. If you can see that on the television screen. And I'm gonna rotate it. Let me get these telescope gauges out of the way. I'm gonna rotate it just a little bit so that I'm checking another part of the diameter with the feet engagement. And I get a little different reading. I get about 970 and 2/10, so that's not much. I'm gonna drop it down lower, about 970 again, and about a little less than 970, maybe 1/10 under. So overall, the hole was bored very well, very secure, or sorry, very smooth. Surface finish is good. Just keep in mind, I checked it in 4 places because I'm checking the entire length and I'm checking around the clocking because as holes about this size start to get out of round very easily. So just want to get you guys in the habit of checking multiple places. So our next gauge is the telescope gauge. So you can use a telescope gauge on a 625 or a 970. Let's do it on the 625 since I just did the 970 hole. So I have one of my telescope gauge sets here, and I've pulled one out. I believe it was this one. So 3/4 to 1 3/4 is bigger than 625. It's not going to fit. Can't get that in there. 3/4 of an inch is too big. So I'm looking for something else. Here's 1/2 to 3/4. 1/2 to 3/4 should fit. So double check ours. Compress it. Okay. And we're going to compress it in there. And we're going to let it seat well. All right, and I'm gonna try to get it until I feel that it's vertically good. Then I'll lock it down. And then as I pull it out, I'm gonna see how the slip fit feels. Feels pretty good. It's always hard to get it perfect, but I can't really twist it that much. And when I pull it out, it's engaged on both sides. Now, before I measure it with my micrometer, I'll verify my micrometer. Ooh, a little bit over. You can see that. I probably have something on my anvils. So we'll grab our print and we'll just clean off our anvils. All right, a little bit under, which is what we've been getting in this series. And I think, actually, I think this may have moved a tiny bit. So I'm gonna adjust it. So, here we go. It's only been it hasn't been that long since I ran the video where I adjusted this micrometer into spec, and it's gone out just from regular use. Could be temperature related, but I'm gonna grab my wrench, and you can watch me calibrate this one more time. So I would say it's, maybe I gotta move it 2/10. So the way I like to do it is just put it back roughly where I was. And I say roughly because I can't really control how much I move this sleeve to begin with. Oh, gotta go the other way. So I'm throwing this in the hole so I can get some leverage. And I'm gonna push it towards lining up. Try to get the 0 to line up with the other 0. Okay, I got it to move a little bit. Let's check it. Ooh, looks pretty good to me. There we go. I think I know the secret for making the camera focus. looks pretty good. So can't, I could probably do a little bit better than that, but it would take me a long time, and I'm actually fairly satisfied with how closely that got in. So now we're ready to measure across our telescope gauge. So to do that, I'm gonna hold my micrometer and my pinky here, and let's cover up those. And just like any other time you measure over a gauge, whether it's the telescope gauge, a small hole gauge, or if it's a whole micrometer, a tubular micrometer, tubular inside micrometer. The technique I'm about to show you is always the same. With the anvils you're going to measure over, you're going to have to clock it in this direction as well as the twist direction. So the whole time I'm doing this, I'm going to be kind of rocking it and twisting it and just trying to sweep. I've got it registered on the back anvil, so I'm pivoting on that back side. Let's get this a little closer. Okay. With my right hand, I'm holding the mic and I'm gently bringing it in. I'm not going to be able to use the ratchet for this. It's going to have to be by feel. That feels pretty good when I can slide it through. And like I said, when you can twist it and it feels like it's engaged as you rotate it. So it's a little bit hard to keep it fully rotated, but it feels all right. Most people, first time they do this, even the 20th time they do this, they don't get it straight. They're too heavy-handed. They're clamping down too much, and it's not just barely slipping through. You just got to find that point where it barely slips through. So I think I'm there. I don't do this every day, but I think I've got the feel that I'm used to. It's going to read that as 625 plus 17, so that's 642. Just under 642. I don't need to know the 10,000ths for this hole because of the tolerancing, but if I say it's 642 with a telescope gauge, let's do our sanity check. There we go. 625. So, what did I do wrong? I've still got it locked, so I should be able to put it back in. Feels good. Feels good this way. Feels good this way. Did I read the micrometer wrong? That's always possible. So I'm actually I see the problem. I didn't have it clamped down tight enough. So one of the downsides, I don't know if you saw it on the video, one of these sprung loose. So you have a clamp back here. It's not necessarily the best clamp available. So unfortunately, it came a little bit loose. So I've got to redo this measurement, and that's okay. You live and you learn, even me. So I'm gonna clamp this down once I feel like I've got it centered reasonably well. All right, put a little bit more force on it this time. And now I'm gonna grab my gauge. I'll be careful not to move the anvils with too much pressure. There we go. So I got the slip fit I want, rotating it around. and I'm pretty much right there at 625. I can just barely, seems to like the white paper there. I can just barely see that line right at the thimble. So 625, and that's exactly what I got with the caliper. So looking good with a telescope gauge. The other one you could do is the 970. I'm not going to do both. I just want to show you guys how to do each one and let you guys do the rest of them. But recommend you practice as much as you can before you really need to do these real inspections on real parts. So it's fine to make a mistake here while you're learning. You've seen me make a couple throughout this series, at least a couple. So it makes no difference when you're learning, but when you start doing real parts, you're going to want to be a little more accurate and better prepared. So next up, we'll do the small hole gauge, and we'll do that 375 hole that we found was large. Let's figure out exactly how big it is. So got a 375 plus 5/10 minus 0. Trying to angle this right so you can see it on the TV. So we've got our small hole gauge set here, and we have some ranges. So we're looking at about 375. So 0.3 to 0.4 is going to be the one we want, which I have right here. And I have the angle, or I have the anvil pushed all the way out, which is how we want to start. And as we push this piece in by twisting, it's going to spread open the anvils for us until it reaches the diameter that forces it to stop. So we're going to put this in the hole. Yeah, I can raise this a little bit. You see how far it's gotten already. This is how far it's spread. This is how far it's spread already. So haven't yet reached the point where now it's starting to grab on. So I'm gonna let it slide and slowly twist. And when it just starts to grab on, you'll feel it, some resistance, and you can pull it out. And once again, we'll grab our micrometer. We've already calibrated it. And let's measure across it. And then it's the same thing. I'm just trying to find the point where it pivots through. I would say that feels pretty good. I've got it registered on the fixed anvil, and I'm pivoting on there, and I'm bringing the moving anvil in. All right, let's take a look at our micrometer reading. So I can see 0.375 plus about 5 thousandths, 380. And that's what we saw with the pins. So the pins, I think the 379 slid through pretty easily. With the small hole gauge, it told me 380, and that could be it because it's hard to know exactly when you stop. When you start to feel the resistance, it's never going to be that accurate, which is why I don't like using these very much, and I much prefer using the pins. Now, if you really need a number, this might be something you need to learn how to use and get mastered, but I don't think a lot of people are going to require you to actually know the size of the hole. They're just going to want you to verify that it's within the tolerance. So there's more holes you can do with the small hole gauge. I recommend you practice, just like the telescope gauge. We will move on. So the next one on here is the Tubular ID Mic, and this part doesn't have any holes big enough for that. And in fact, the part that I have, pretty much the only part that I have, I showed you how to do in the other video, in the training video where I talked about all these gauges. So in the interest of time, I'm not going to show you the exact same thing. It's a little bit of an involved inspection. So I'd like you guys to just go find the video where I actually start off with with the small hole gauge, and you can just follow along with me as I measure this part and set the 0 on a ring gauge. But next up, the dial bore gauge. So once again, I did that in another video, but I actually have another hole we can do. So the dial bore gauge that I've got has a range in the 625 or the 970 hole that we can do. So I have this set up for the 970 hole. So I have my dial bore gauge here, and I've already gone through the trouble of zeroing it on a ring gauge. So I know when it's zeroed, and I'll be able to track how far the dial moves from its 0 to the part. And I'm going to record a video. I've mentioned this before. I am going to record a video where I set up this dial bore gauge from the beginning. You have to set the location of the dial. You have to choose the right tips. You have to zero on a ring gauge, and then you have to set it on the part. So I've already done the zeroing, but we're going to verify that real quick. So to do that, I will, first of all, there's a little anvil back here, spring loaded, that moves. So this is what we're going to have to push in order to get in there. And then this little guy, this little needle point, when I push on that, moves the dial. Okay, so that's what's pushing in, and this side is just a hard rider. It's just a hard stop. So I'm going to put it in, and then I'm going to eyeball it up and down. I'll swing this around so that you can see from the front camera. And what I'm looking for in the TV monitor that I'm watching is the inflection point where it starts to pivot. All right, there's the maximum, right about there. Can't really see it from my angle, but when it starts to turn around, I know it's straight, and now it's not straight. And when it's straight, that's when we want to set our 0. So let's hold it up to the camera. I'm gonna hold the ring gauge off camera like this, and I'm gonna try to get this on camera. So I'm looking for the high point. There's the inflection point, right about there. And I'm not skilled enough to show you on the camera, but what I'm gonna do is I'm gonna twist this dial until the 0 lines up with the same spot that the inflection point is. So I'm gonna look for it where you can't see it. Maybe you can see it a little bit on the monitor there, but I'm looking for the inflection point, and I'm just rotating the dial, okay, until it reads 0. It's a little tricky. There's a little trial and error involved. Seems to be a little more tricky than usual right now, but I don't use these things every day. All right, that looks pretty good. Let's see if I can hold it up to the camera. So if I did this right, it will flip back right at the 0. It's just a hair different than the 0, and I think that's because of the way I'm holding it. I can't get it exactly how I want to. It's a little bit tricky, but I hope you can trust me when I say that when I'm looking at it from my point of view, it's pivoting right on the 0. So now, one thing I didn't point out, this is very important. You need to pay attention to where that small dial is when you read 0, because you're going to be tracking how far that small dial moves. If we say 1 inch is 0 and its small dial moves some distance away, you're going to have to take that and subtract it from 1 inch. So we're zeroing on 1 inch or whatever size ring gauge that you have. This is basically a 1 inch. It's 40 millionths short. So let me hold up to the camera about where that second gauge is. So that second dial reads 0 just a hair before the 4, okay? And every time we go around the dial, if you look at that, if you look at that second gauge there, so 0, I'm gonna go around 1 revolution, it moved 10 thousandths, okay? So that's how we know 1 full revolution is 10 thousandths based on where the small dial moved. The large dial is telling me I'm going 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay? So we've got it zeroed. Now we're gonna see relative to 0, what are we measuring? So I'm gonna drop this in, take a reading, and let me take a reading real quick, okay? I can see exactly, I'm gonna flip it around and show the camera, and I do the exact same thing. I look for the inflection point. So I'm getting closer, and when the needle stops, it's moving straight, and then when it flips back, right there is right about the highest point. So I know I'm getting to the straight when I'm looking at it directly. Now let's take a look at on the camera, what that looks like. So I'm gonna do my best to pivot this the way I was seeing it. This is pretty much how I saw it. So it's pivoting right about there. And look at the small dial. The small dial was at 0.04, and now it's moved all the way to 0.01. So we have moved 30 thousandths and 4 tenths based on the line that I'm seeing. So 30 thousandths and 4 tenths. So we zeroed on an inch, and now the dial is 30 thousandths away from an inch, smaller. We know it's smaller because as you're pushing this, as you're pushing this in, the more you push it in, the more the dial moves, which means if this anvil on the back is being pushed inward, it's getting smaller. So 30 thousandths subtracted from 1 inch is going to be 0.970. And on our print, right, that is the print nominal, 0.970. And we'll verify that with our micrometer. .968. Again, I've said this before many times, you're never going to get exactly the same when you switch gauges. This caliper is just a sanity check. I would trust the dial bore gauge. It's a more accurate gauge. But I know I'm using it right. All right, this took me about, this took me 10 or 15 minutes to use properly. So it's nice to have a sanity check at the end of that. All right, so we've gotten through probably the hardest gauge, the dial bore gauge. Next up, we're gonna do the dial hole gauge, and that'll be the last one we do. And maybe I'll finish with the caliper. So let's look at our dial hole gauge. Oh, I already pulled it out. So before I start using it, let me show you the whole set again. So here's the whole set. From the last video, I showed you how you can interchange these anvils by twisting them off and screwing them back on. Now, when you're choosing the anvil, what I do, I will grab an anvil, and it's basically at its maximum size, at its loose size, it is at its maximum size. So I'll take this and I'll drop it in the hole. And if there's a little bit of pressure involved, I could probably use that anvil. If it drops straight in with no resistance, it may not be good enough. So you may find yourself a little bit of a trial and error, but if you at least get yourself in the ballpark, if you grab a big one that doesn't even start, you also know it's too big to go in. It won't get any smaller and it's not even going to start. So I've already got this one loaded because I know it's going to work. I already tested this before the video. So let's show you how I do that. Each of these anvils come with its ring for setting. So the setting ring is marked as 0.7. So this is similar in concept. We're going to measure. Oh, you know what? There's another mistake I've made. I've got the wrong anvil on. So I was setting this up and I must have grabbed the wrong anvil. So here's the pin that we don't want to lose. Here's the anvil that I know doesn't fit because I can't even get it in the hole when I compress it myself. So I'm going to grab the correct anvil that just slips in with a little light, basically the touch of gravity, slips it in, and drop that in, screw it on, and then we will, there's some wrench flats here that you can give it a little tight twist, and really finger tight, usually good enough. And as this anvil depresses, it moves the dial. And again, we're gonna have to pay attention where that little dial is when we zero. We're gonna zero on something that is 0.650, okay? So we're gonna track how far away we move from 0.650. So I'm gonna do this. I'll try to show you on the camera first. Definitely way off, right? Trying to zero this on the 650, and my needle is way far away from zero, so I need to rotate the dial. I'm going to eyeball it first. I'm just twisting the main dial. I'm going to try to drop that back on. And I got really close. So I'm going to eyeball it back. Normally I would be looking at it head on, but I think I can do this on the camera. Maybe I can't. So I got just a hair class 0. I'm gonna look right at it while I set the 0. Okay, that looks good to me. So it's set for 0 on 650, and the dial, the small dial, it's pretty close to that third line. So it goes 0, 1, 2, 3. I think it's right there on the third line. And we grab our part and we'll take a look. Now, let's look at that small dial. We're there on the 6th line. We're on the 6th line plus about 13. So we've gone from the 3rd line to the 6th line. So 3 rotations on this dial is 80 thousandths. Kind of an unusual dial. I've never seen one that wasn't 50 or 100. So that is 80 thousandths is 0.240. And then that last number we did see on the dial, I'll recreate it. It was at about the 13 mark. So 0.240 plus 0.013 is 0.253. And so we do 0.650 minus 0.253. That is, I think I do this one in my head, 0.622. Okay, does that sound right? Somebody double check me with a caliper, or sorry, with a calculator, but we'll also double check with our caliper because I don't remember the reading before. Yeah, there it goes, about 622, 623. I'm in the ballpark again. I got a more accurate reading with this one, once again, than my caliper. So I'm going to trust this reading. I feel pretty confident with it. If it were a precision hole, it's got a good finish, so I would trust using the dial hole gauge in this instance. So last up, I know it's to go over a caliper again in the same video as the hole inspection is kind of redundant, but in reality, you're going to use caliper a lot anyway. So the nice thing, one of the nice things about the caliper is it's fast. All right, so you go 624, 379, 396, 397, and look, I'm picking up that burr that I was telling you at the beginning of the video, 392, 391. So yeah, caliper is faster and it did all these holes. And for the purposes of this print, there's only one precision hole on this print. So if you're asking yourself, what gauges can you use on everything but this hole in the corner, you can use a caliper because we want to make all of our decisions based on tolerance zones, obviously. We don't want to just be choosing at random or choosing because what we're comfortable with is using a caliper all the time, but there's more to it. The tolerance zone should be first, and then how comfortable you are, how accurate the gauge is, those also factor in. So let's, now that we're basically done, go ahead and finish the rest of the part with the other gauges that you may have. Record your values, and we'll move on to the questions. So let's take a look at some of the review questions. Let me zoom this in real quick. Sorry, the monitor where I can see is a little bit smaller than I would prefer. Here we go. All right. So we've gone through this exercise, and let's just discuss these questions. Now that you've done everything, now that you've watched the videos. So number one, what are your thoughts about using the go, no-go gauge pins versus taking actual measurements? What are the pros and cons? Just think about it. I would say the pros of the gauge pins are they're fast, they're accurate, they're easy. Sure, you have to verify with a micrometer at the beginning, but if you've got a lot of parts to do, it's a great way to check a lot of parts. Downside is, yeah, you don't get a number. With a caliper or some other gauge, you will get a number, and sometimes you need to know the number. There are cases definitely where you'll want to know the actual number, and you may want to pull out the whole micrometer. That's your next most accurate gauge. So those are some pros and cons. Think about it some more. Discuss it with people. Ask them what they like. For each gauge, describe a situation where it is the best and only gauge for a job. Consider feature size, location, tolerance, other things. Use examples from this exercise and compare against calipers. So really the whole point of it is I've shown you, 6 to 8 different styles of hole gauge. All of these have like a perfect application. For example, the style bore gauge, it's tricky to use. I'm not going to deny that. I'm not going to lie about that. It's for beginners and even for me, it can be tricky. But if I've got a deep bore, if I've got a bore that's 12 inches long, what else are you going to use, right? These 3-point mics are really nice for measuring down to an inch or two, but beyond 3 inches, how do you even hold it if this thing is sitting so far deep into a hole? You're not going to get much. There are extensions for these, actually, so keep that in mind. You can extend this about 4 to 6 inches if you get the right manufacturer's extensions. But in reality, if you got a really deep bore, this one's great. If you've got some small holes and you got to do a lot of them, right, and you want to know a number, you got a lot of small holes and you got to do a lot of them, a dial bore gauge could be great because you can just drop this thing in, have it zeroed on something you already know, and you're just looking at the difference. Telescope gauges are good, occasionally when you have a weird diameter that you don't do very often, you don't have tooling for. They're a very cheap alternative to purchasing something more expensive, and they have a big range. I mean, I've got this 3.5 to 6 inch range right here. So odds are you've already got the mics. Probably if you're working in that size of part, you probably already have some 6-inch mics. So if you're going to use if you're going to buy a telescope gauge for the occasional bore, that's a great fit for it. The tubular hole mic here is great for big diameters, those 20-inch, 30-inch diameters that all these other tools are too small for. So keep thinking about that. Think about your own job, your own career. If there's something here like, oh, I wish I had that for this project, or oh yeah, we've got this coming up, maybe we should consider getting another gauge for it. So just give that a shot. Think about that. Which gauges were the easiest to use and why? And when you're thinking about, obviously, the easy ones, but when you're thinking about the ones that aren't easy, why is that? What do you need to practice with? Is you're struggling something that's going to keep you from using it? It takes a long time to get the dial bore gauge set up, but the results can be very accurate on those diameters if you need it. So what's holding you back? Is it just practice? Do you need somebody to help you? Do you need an easier way to set it up? You can talk to people about that. Next up, which gauges were most difficult? So 3 and 4 pretty much already discussed. Number 5, what was your experience with the 3 transfer gauges, right? So we have the telescope gauge, the small hole gauge, and the tubular micrometer, all transfer gauges. What do you think about those, right? What do you like? What don't you like? At first I didn't like them that much until I got used to how they feel and how they slip. And then they have their place for certain situations. It's what I would choose to use. If it's less than 2 inches or so, I really like having these hole micrometers because they're relatively inexpensive and very accurate, but I don't always get to measure things less than 2 inches. So sometimes telescope gauges come in handy, especially the tubular micrometers. I used to measure large bores all the time using a tubular micrometer. It was the only option I had. It was that or a caliper. So I preferred using the tubular micrometer. Number 6, if asked to inspect the hole with a diameter of 0.995 plus 1,000th and minus 0 that extends to a depth of 10 inches, what is your preferred order of gauges and why? So I'm not going to really tell you. This is going to be up to you to think about it. But, the more you do this, the more you're going to say, ooh, man, I've got this project. I've got to measure this part. And I've got like 3 different ways to do it. And you're going to have to come up with the best way to do it. And sometimes your first way may be the way you want to do, but it doesn't work. And you have to go to plan B, plan C, plan D. So I want you to think about that because plan A doesn't always work. I throughout my career, I've failed often at plan A, and I've spent a lot of effort trying to get that first idea, the one I think that's going to be great to work. And then when I finally get there, it's like, oh, this isn't what I thought it would be. So think about all your options, right? Don't just give up and don't just assume there's only one way to do things. There's usually more than one way. And finally, for number 6 and for number 7, consider all the gauges and consider all the ranges that are commonly available. That will help you with answering number 6 and number 7. What I've got here, what you've got probably at the video is probably not the entire range of tools, but think about what's commonly available. And I did have a chart in the summary video that summarized the common ranges of these gauges. So take a look at that if you're struggling with question 6 and question 7 that we're about to go over. So question 7, here's another hypothetical scenario. If asked to inspect a hole with a dimension diameter 3.5 plus or minus 1,000th, extends to a depth of 0.125 below the surface, what is your order of preferred gauges and why? So the first question we just did a couple minutes ago extended to a depth of 10 inches. And this question is extending is a large diameter that's very shallow. So these are kind of the extremes of what you're going to see. Well, we were dealing with, here's the part. When we were dealing with this part, we were dealing with commonly available, reasonable depths, reasonable sizes, easy to work with. That's what we want for the training purposes. But in reality, you might get some really shallow bores. You might get some really deep bores. So for this shallow one, what I want you guys to consider is, well, how big is your anvil, right? How big is the body that you may need to clear? So is 0.125 enough surface area to grab onto? On our caliper here, let me flip to the other camera. Here's 0.124. This is how big 0.125 is in relation to the anvil. So it's smaller than the anvil of this telescope gauge. And what about your other gauges that you've worked with? How much surface area do you need for engagement? What if it was, instead of 0.125, it was 0.12, 12 thousandths? Not a whole lot of applications for that, but could you even register anything on 12 thousandths of an inch? Let's take a look at that. I've worked at a company that would have very tight tolerance, very shallow bores. If your bore is only that deep, this is 17, how are you going to measure that, right? Now, my example is at 0.125 is a little more reasonable. Okay, here's 0.136. It's a little more reasonable in this size, but think about it, right? How much engagement do you need? Give it a shot. Number 8, we'll flip back. What errors, I won't even change the camera. What errors, what feature or user errors could easily throw off the measurement of each gauge? So with each gauge, you can definitely mishandle them, right? For example, with pin gauges, you could grab the wrong pin very easily. Seen it done many times. Somebody put it back in the wrong tray. You grabbed it from the tray you think it is, and it turns out to be a different one. For a 3-point hole mic, I've mentioned how you can register this on a radius at the bottom of a hole instead of on the sidewall. Allow me to draw that real quick. When you're measuring with a 3-point hole mic, you've got this hole. Every manufacturing process leaves some witness in the corners. Sometimes they're very sharp, and other times they're very large. And if your anvils are hitting right here instead of out here, it's going to give you a false reading. Okay, so that's one of the main things to keep track of with a 3-point mic, is that you're not on the radius. Raise it up a little bit if you think you are. Same thing, you can have them, instead of perfectly straight up and down, you might have it cockeyed. You might have it on a chip you can't see. It could be anything. An ID mic, you've seen me struggle with the tubular ID mic. Same thing with a telescope gauge. You have to have this thing perfectly aligned, left, right, up, down. You got to think about that while you're doing it. Make sure everything's lined up perfectly. Telescope gauge, the small hole gauge, right? These, you can definitely apply too much pressure when you're extending this into the hole. It's hard to feel the resistance right away. You might get 1 or 2 thousandths or even more of extra crush that you didn't want, but you didn't feel it. So you have to have a very light touch. So there's more, give it a, think about it. Calibration errors, right? You can calibrate all of these a little bit off as well. So just remember that as you're step by step going through this, each step needs to be good. So that's it for this exercise. I want to thank you guys for following along with me, for watching these videos. I would ask that you go to the pragmaticmetrology.com website, look for more videos, more exercises. Once again, I'll mention you can find CAD drawings for these parts that I'm demonstrating with. You can find the exercises there so you can practice at home or at work. You can see more videos. And I also, again, I want to thank the Laney Machine Technology Program in Oakland, California at the Peralta District. They've provided the parts that I've used for these videos, as well as a lot of the tools. And it's a great program where you can learn about manual machining, CNC machining, inspection, metrology, quality control, 3D CAD, CMMs. They have a lot of great courses. It's in the Oakland, California, Northern California Bay Area. Offer classes in fall, winter, and spring, year-round basically, and even offer certificates you can earn, 2 years certificates, associate's degrees, apprenticeship programs. They know a lot of great employers in the area that can either help you find a job or help you advance your career. You'll get to meet other students that are working full-time or other students that are entering the workforce, but it's a great place, and I recommend you check it out if you're looking to learn more about manufacturing industry, metalworking, inspection, quality control. So thank you guys. And again, please check out my website, pragmaticmetrology.com, and I will see you for the next video. Thanks.